In this video, we're going to be doing some analysis of graphs of functions. So if you look at example 1, you'll see we have a function here. We have a dotted line called an asymptote, which means that that graph of that function gets continuously closer and closer to that line but never touches it. That's all that means. So it says find f of 5, remembering that the number in parentheses by that f refers to the value of x. We would count over 1, 2, 3, 4, 5, and then come down and see what the value of the function is when x is 5. And you can see that the value of f of 5 is -4. Find f of 4, 1, 2, 3, 4. Again, that is our x. I come down and you can see that the value there, it's hard to tell because the graph is kind of thick. It's either -3, -2 2/3, -2 3/4, something close to that line. I made my dot big so it looks like it's on the line, but before I did that, you could see the graph, it wasn't quite at -3. And then f of 3, 1, 2, 3. F of 3, now that one's easy to tell. When x is 3, the function is 0. So you understand what we're doing. All right, let's look at the next one. It says, is f of -1 positive, negative, or undefined? So we want f of -1. That means x is -1. Well, the graph doesn't even go over there, so it's undefined. There is no function when x is -1. Is f of 2 positive, negative, or undefined? 2, remember what I said about this dotted line called an asymptote. The function never reaches it. So again, the function is undefined at f of 2. Is f of 2.5 positive, negative, or undefined? So 1, 2.5, and I come up and I can see, oh, there I can see what it's equal to. And it's in the positive quadrant as far as the y's go. What about f of 10? Well, I don't know. My graph doesn't go out that far, but it's going to be down here somewhere. And since this continues, I can see that it's going to be negative. So we're just looking at that graph and seeing what it tells us. Let's look at another one. Example 2, it says, for what values of x is the function, which is f of x, greater than 0? Well, I'm going to use a different color so you can actually see it a little bit better. The function is greater than 0, meaning positive, right here. So the question is, for what values of x? Is that true? Well, it starts at -1, 2, 3, 4. So it's -4 to 4. Now notice something. I didn't include the -4 or the 4 because at those points, the function is not positive, it's 0. So that's not positive. So those aren't included. Those are just the end points. So 1, 2, 3, 4 and -1, 2, 3, 4. All right. For what values of x is the function less than 0? So where is it less than 0? Let's do that in green. The function is less than 0 here, and then it gets positive, and then it's less than 0 here. So how would we describe that? Well, it's going all the way down to -infinity. So we would say -infinity to -4, not including -4, remember, because at -4, it's not negative, it's 0. In union with, it starts back being negative at 4, going down to positive infinity in this direction, going right to, not down to. All right, let's look at the next one. For what values of x is the function greater than 0? On this one, let me use a color again, and we can see that it's greater than 0 all along there in that region. Well, where does that start? Being greater than 0? Well, right up to 2, it's greater than 0, not including 2. And then where does it continue? It continues to 3. But again, it doesn't it's not positive at 3 because f of x is 0 at x equals 3. That's right here. So this is an interval that does not include the endpoints. It doesn't include this endpoint because it never reaches 2. It doesn't include this endpoint because it's not positive there. All right, for what values of x is f of x negative? And again, that is represented by this green area right there, the green part of our graph. Where does it start being negative? It starts at 3, not including 3, and then it goes down to the right to infinity. It is still in negative land in that direction. So that's just reading a graph and understanding what you're seeing and being able to answer questions about that particular graph. Let's look at the next page. We're going to continue in example 4. If x is 0, what is f of x? Well, where is x 0? X is 0 right here. Not here and not here. X is not 0, y is. But x is 0 right here. So it says, what is f of x if x is 0? So we want to know f of 0, and that would be 1, 2, 3, 4, 5, 6. So f of 0 equals 6. All right, here, for what values of x is f of x 0? That's a different question. Here we wanted x to be 0. Here we want the function to be 0. So where is the function 0? The function, meaning y, is 0 here, here, and here. Those are the 3 places. So what we want is f of x to be 0, and that happens at f of negative 4. 1, 2, 3, 4, that's right there. It's 0. F of 0 is 0. And f of 1, 2, 3, 4, 5 is 0. So make sure you understand the difference between these two questions. The first one is asking me if x is 0, what is f of x? The second one is saying, what is x that makes f of x 0? All right. Let's look at the function in example 5. F of x equals x plus 1 over x plus 2. And by the way, this is a very typical question that you might be asked. Is the point 1, comma, 1/2 on the graph of f? Well, how would we figure that out? Well, I know that this is a coordinate point, x and y. So all I'm asking in this question is if x is 1, is y 1/2? So all I'm going to do is put a 1 in for my x and see if I get 1/2 for y. If I do, then yes, that point is on the graph. So to do that, we would take out the x, put in a 1, take out the x, put in a 1. That gives me f of x is equal to 2/3. So is the point 1 1/2 on the graph? No, it's not. It's not on the graph because 2/3 is not 1/2. So it's as simple as that. Don't make it complicated, more complicated than it is. You're just not used to the wording. Let's look at part B. If x is 2, what is f of x? Now that's a pretty easy one to do. So we're going to put a 2 in. We want to know what is f of 2. That would be 2 plus 1 over 2 plus 2, or 3/4. So when x is 2, f of x is 3/4, but then it continues what point is on the graph of f. The point is x is 2, y is 3/4. So that is the point. There's the 2, there's the 3/4. So that's why function notation is so handy, because you can see so much more from function notation than an XY table. If f of x equals 2, what is x? Now this is a different question than B. It's the way these two were different up here. Here I'm not saying put a 2 in for x. I'm saying put a 2 in for the function and see what x is. So how would we do that? We take our function, x plus 1 over x plus 2, and we set it equal to 2. X plus 1 over x plus 2. Well, how do I simplify that to figure out what x is? Very easily. We get rid of the denominator like we do always when you have a fraction in an equation. That cross cancels. On my left, I have 2 times x plus 2 equals, on my right, I have x plus 1. 2x plus 4 equals x plus 1. This is linear, so I'm going to get my variables on one side, numbers on the other. So that gives me x plus 4 equals 1. I subtract a 4, x equals negative 3. And can x be negative 3? Yes, because that's not a domain restriction. What it can't be is negative 2. So it says what point is on the graph? This is my x, so the point is negative 3. This is my y, 2. So make sure when you figure these out, you can then draw the conclusion of what point is on the graph. What are the x-intercepts of the graph, if any, and what points are on the graph of x? So the x-intercepts, think about any graph. Whoops, let me scoot this over so you can see it. An x-intercept of any graph is where it crosses or touches the x-axis. So when it's on the x-axis, what is 0? Not the x, the y is 0. So again, I'm going to take my function, and this time I am going to set it equal to 0 to find the x-intercept. So x-intercepts, let y equal 0. That's how you do it. Multiply by the LCD again to get rid of the fraction, and I get x plus 1 equals 0, or x equals negative 1. So it says, what points are on the graph of f? Well, the only points that are on the graph is negative 1, 0. That is on the graph. That is the x-intercept, and it's the only one that we have in this case. All right, let's look at another one like that. It says, let f be the function whose graph is given here. And this is, the start of it is labeled, and we need to do some more labeling. And actually, if you look at the next page, you're going to see that same graph. Right there it is. And it actually might be easier to label it on this page just because it's larger. And then we can answer the questions that begin on the first page. So let's label this page first. So we have 0, 4. Here I have pi over 2, so a half of pi, 0. Here I have pi. So you can tell to get to here is pi over 2, to get to here is pi. So this is going to be 3 pi over 2. So 1 half, 2 halves, 3 halves, 4 halves, which is 2. We're going to finish this in a minute. That's right here. 5 halves goes right here. So 5 pi over 2. Again, we'll finish the point in just a second. 6 pi, which is, or 6 pi over 2 right here, which is 3 pi. Up here, I have 7 pi over 2, and here I have 8 pi over 2, which is 4 pi. Now let's finish it. So 3 pi over 2, what is the y coordinate? It's 0. 5 pi over 2, 0. 7 pi over 2, 0. So do you see how the labels go? We're counting by something you're not familiar with, but you still should be able to do that. Now let's go back to the first question. It said, what are f of 0, f of 3 pi over 2, and f of 3 pi? So f of 0 is when x is 0, what is y? That would be 4. I can read it right off my sketch. F of 3 pi over 2. So let's find 3 pi over 2. Here is 3 pi over 2. What is my y? It is 0. And then f of 3 pi, going back to my sketch, where is 3 pi? Here it is. What is y? It's negative 4. So f of 3 pi is negative 4. So I'm just reading straight off my graph. And actually, I could have read that one right here. It's right here. Not all of them were on there, but that one was. What is the domain of f? Well, that means how far to the left and the right do my x's go? Well, this doesn't have arrows on it, so it looks like it stops right there. Does it include the 0? Yes, it does. So the domain, as an interval, it includes 0. How far to the right does it go? It goes up to right here. We can see x is 4 pi, and it is included because I have a value for y there. What is the range? That is how far down to up my graph goes. Well, the lowest that my graph goes, the lowest y, is a -4. So the range is a -4. How high does it go? The highest that it goes here, here, and here is a +4. Continuing to answer questions about our graph, it says list the intercepts. The y-intercept is usually easier if you're given an equation, but if you're given a graph, you can find both the x and the y-intercept. So I'm going to go up here high because there's several. The x-intercepts are where my graph crosses the x-axis. So here's one, pi/2, 0. Here's another one right there, 3 pi/2, 0. Continuing, there's another one, 5 pi/2, 0. Continuing, I have another one, 7 pi/2, 0. Those are my x-intercepts, reading right off the graph. My y-intercept, I only have one. It only touches this y-axis in one place, and it's right there. It's the point 0,4. So that we have done. How often does the line y = 2 intersect the graph? Well, what would the line y = 2 look like? Any y equals is a horizontal line. So 1, 2, it's going to go across here horizontally. Mine isn't exactly straight, but it doesn't matter. How many times does it intersect the graph? Just count. 1, 2, 3, 4. It intersects the graph 4 times. At what value, this is f of x, does f of x equal -4? So we want to know where are the y's -4. Well, here it is and here it is. So there are 2. So I could say f of pi equals -4, or I could say pi -4 is the point, and f of 3 pi equals -4, or I could say the point 3 pi -4. You can answer that either way. Finally, for what values of x is f of x greater than 0? Let's use a different color here. All the places it's greater than 0. It's greater than 0 right in here. It's greater than 0 in here because it's above that line. And it's greater than 0 along here. Now, I was kind of sloppy with that, but I want you to be able to see it. So for what values is my function greater than 0? Well, it's greater than 0. There's several ways we can say this. I'm going to say it like this. F of x is greater than 0 when I can say, let's talk about this blue one first. The first region is between, x is between 0 and pi/2. So that's this region. X is between 0 and pi/2. I'm talking about my x's here. And then there's a break, right? So we're going to say in union with, because it's not continuous, it's greater than 0 here. What are the x's? It's when x is between 3 pi/2 and 5 pi/2. Okay? But that's in union with, now where else? It starts here 7 pi/2. So 7 pi/2, x is between that and 4 pi. So x is between each of these regions that I showed on my graph in blue.